Hello dear students, this is Mr. Mario with a new tutorial. Now, today we will learn how to create a simple walking robot using Tinkercad SimLab. So here I am giving you two examples. We can see that there are two basic walking robots, each one with one weapon. Okay, perfect. So for this exercise, I will teach you how to create the simple walking mechanism. Now it will be up to you to customize your robot, to add more weapons, to add more accessories. It's up to you. Okay, so let's open here our Tinkercad and let's call this simple walking robot. Okay, settings, I will say 400 per 400. Okay, close settings, good. And because this is a mechanical construction, I will use the ruler. The ruler is always very useful. Okay, first thing I will bring a simple box here. Okay, good. The dimensions of our box will be 50 millimeters of front, 40 millimeters of, let's say, side, and 80 millimeters of height. Okay, good. So 80 per 50 per 40. Okay. I will change it. I will change the color. Let's make it green. Okay, good. Even if you want at this point, you can add some kind of decoration to remember that this is the front. So here you find eyes. Here you use a head. So your choice. Okay, I will bring these glasses. This is optional. Okay. Remember, these glasses are optional. Any decoration. If you don't want to decorate it now, wait uh, until the end. Okay, good. And let's align. Okay. So why am I adding the glasses? So we know that this is the front of our robot to avoid confusions. Okay. I will group it. Remember, multicolor. Okay. I think this will do for the moment. Now, there is a simple way to do here the crank mechanisms, and it's with only one cylinder. Probably in some of my previous lessons, you saw that I used two cylinders, one per each side, but you can achieve the same result with only one cylinder, and that will simplify the task. So I'm going to basic shapes and bringing this cylinder here. Okay. I will change this color to yellow. Okay. Now the dimensions of this cylinder, I will make it 60 of length. Okay. 60 millimeters. Yes. And the diameter, it will be 20. 20. Let's leave it that way. It's perfect. 20 this way. Good. Okay. Now, I'll select the body and the cylinder, and I will align to the middle. Good, as you can see, it's perfectly here in the middle, and here, perfectly in the middle. Good, perfect. Okay, maybe a little bit down, perfect. Okay. Now, is one cylinder here. So, I will bring from Sim Lab, I will bring one axle connector, and I will place it here. Okay, so first I need to align this connector to the center of this cylinder. So clicking Shift, yes, the Shift key. Okay, let me search for, let's see if we have the keyboard here. Okay, keyboard. I notice no. Keyboard in documents. Okay, in photos. Well, let's see. Oh, perfect. We have our keyboard here. Sorry for the delay, but it's just in case if you don't know where to locate the shift key. So, using the shift key, remember, shift is our magic key when we use Tinkercad. So, using the shift key, I press shift, keep it pressed, and I select the axle and I select the cylinder. Good? Okay. Now I need to align. So I click align L. But before aligning, I need to confirm which part will be the center of reference. So I need to click the cylinder. Good. So I click to this middle, I click to this middle, and as you can see, our connector is right in the center. So perfectly, per perfectly centered. Okay, good. Now, in this case, I will connect the connector, yes, to the part. So the orange will be the body, okay? So the orange component, the base component will be the body of the robot. The blue component, the mobile component will be the cylinder. Good. So as you can see, this way we don't have to add cylinder to each side. With one cylinder is enough. Good. So again, orange component is the body. Blue component is the cylinder. Very good. In this case, let's add a bit of motor torque. So I will give maximum torque and motor speed, I will say 50. So one more time. Motor torque, I am giving maximum torque 170 to make it more powerful. And motor speed, I am adding just 50. Why only 50? The more speed I add, the more unstable will be our robot to walk. So it's up to you. You can experiment with the torques and with the speed until you find the best combination. Okay. Now, next, I will bring another axle connector to this side. So axle connector here. Good. right side, orthographic, switch to flat view orthographic. Okay. Now, in this case, I want to align this connector to this one. Good. So, I will click Shift. I select this connector. I select this connector, align, and I select again this connector because this will be the point of reference. Good. Center. Perfect. So check that the two connectors are aligned. Okay, we are using both axle connectors. Let's change point of view from view. Okay, good, perfectly aligned. Now, after doing this, I will select the cylinder and the two connectors. Good. Then duplicate. You can use this one. Duplicate and repeat. Command D, Control D, your choice. And using the arrow, this arrow, I am bringing the duplicate down. One more time in case it was not clear. Using this arrow or using, if you are in a Mac, command up or down arrow, or if you are in a Windows, control up or down arrow. Yes, you can bring the duplicate down. Good, this will do for the moment. Yes, verify that they are perfectly aligned. Yes, so far we have these two connectors that are not connected to anything yet. Don't worry, we will solve that problem in a few minutes. Okay, good. Now we'll create one leg. So first thing we will do is bring a box. So I am bringing here from basic shapes. I am bringing a box. Okay. The dimension of that box will be, the height will be 100. And here, the front and the side will be only 5 millimeters, 5 millimeters. Okay. 100 per 5 per 5. Okay. Now next, I will bring another box. So the dimension of this box will be 5 millimeters of front, 5 millimeters of height, and 60 millimeters of side. You see? Okay. Good. And let's put this side 1 minute. Okay, let me put the robot, full robot to the side here, 1 minute. So I have more space to do the next part. So I have this block of 60 per 5 per 5. So I am duplicating it. So remember, Command D, Control D, or this option, duplicate, and repeat. So Control D, oh, sorry. So here, duplicate, and I move 90 degrees to duplicate. Okay. So I place one here. Okay. Let's align it to this border. Perfect, it's aligned. And now this one, I will duplicate it again. Control D, Command D, or duplicate option. And with the arrow key, I move it here. So it must look like this, more or less. Okay. So I check that they are aligned to this side. Perfect. Okay. So I select these ones and I group them. So Control G, group. Good. Now I am selecting this long beam and this long beam. I select both of them, align, yes, align to this middle and align to the side. So it must look like this. Then I select all of this and group, Control G, group. Okay. Now you can see this is one leg is ready. Now let's go to front and here let's make it orthographic. We are in perspective, switch to flat view orthographic, front. Okay. I select the body and I will elevate it 30 millimeters. 31, okay, let's write here 30 of elevation, enter, 30 millimeters, okay. Let's go to top view, and now let's bring this leg. Can you see here the column, this one? We need to align this column to these two axes, the ones that were not connected yet. So top view, okay, top view, using the arrow keys. Remember that with arrow keys is very good when you need to be more precise. Okay. So using the arrow keys, I will bring it here. Good. I think this will be good here. Okay. Let's see. Arrow keys. Okay. I think it will do there. Good. Okay. Now, these connectors, let's connect them. So, I am clicking this connector, the one that didn't have any connection. This to the center, don't touch it. This one, don't touch it. This, the one that is not connected, is the one that we will use. The orange component, the base component in this case is the cylinder. The mobile component, the blue component, is the leg. And here the same in this second one. So the orange component is the cylinder, the mobile component is the leg. Okay, let's test. Just for curiosity, let's test this with only one leg. Working. Very good. So, but as you can see, it's not working. It's just going up and down, up and down. So, I am going to top view, perspective, top view, perspective. Sorry, orthographic. Top view, orthographic. Okay, because I need a flat view for this. So, be careful with this part. Okay, I think it's better if I do it from this side. Okay, so No, better from the top view. Top view. Yes, to avoid risk of, okay, top view, to avoid risk of selecting something that we don't need to select. Now, I will select this leg and the components to this side. So look, the leg and the connectors here. These connectors, these two connectors. Good. I duplicate them. Duplicate and repeat or Command D. Okay. I move them to the right, the duplicates. And I use mirror, our friend mirror. Here, mirror. So I click mirror and I choose this direction. Okay, so I click this direction. So I move them. Now this part is very important because this works like a crank and because we need to be, oh, okay. Let's reduce the snap grid a bit. Remember that here with the snap grid, if you need to advance less, you can modify, let's say 0.1 millimeters. Okay. Let's say perfect. Now, with the arrow keys, I don't need this leg to be here because it will jam the mechanism. I will move it down here. Let's see here. Okay. So you can see the feet are not touching each other. And if you go to the top view, flat view, you can see that they are alternate. So that means these connectors are in the back part of the cylinder and these connectors are in the front part. Okay. So let's test. Let's see if it worked. Okay, play. Ah, here we go. Reset. Let's move this a bit back. So as you can see, it's working. Slowly, but working. So you need to check that this movement is alternate without interfering, without one feet interfering to the other. As you can see, it's fluid, it's going, it's going perfect. Very good. So reset. Now, this is the basic walking robot. As you know, we have, okay, our plan is to have a robot fight. So you can add the accessories of your convenience. Now, if you want to add accessories, I recommend you to use the connector, the pivot connector, to connect it to the robot. Because if you try to group something to the body or something to the legs, probably it will disconnect some of the connectors. So let's better connect them using this connector. So examples of things that you can add. Just some examples. The rest depend on you. If you want to add, let's say, a saw, yes, a buzz saw. So let's say gear. Okay. So this is interesting. Custom gear. One example. Let's bring this one. Sit. Okay. Number of points. Let's add 30 points. Sit angle. Let's add some angle so it looks like a, okay, too much angle. Ah, this will do. Okay, good. This will work. Um, this is an example of something you can do. You can bring here a connector, axle connector, align. To this middle, good. You can bring here another here. Let's suppose here a little box. So this is an example, so I will not stop in dimensions. Okay, good. Now let's connect. Mobile part, blue part is the blue, is the saw. Orange part is this one, good. Blue, orange. Let's add some torque. Let's add maximum speed. Okay. So we can place it here. Let's bring, okay. Let's C, using C, let's bring this on top. If you want some ideas about different accessories or weapons that you can add to a battle robot, you can check on YouTube, battle bots, robot fights, or even you can get some inspiration to from Skibidi Toilet. Yes, yes, I am a teacher. I said Skibidi Toilet. Deal with that. Uh, it's a very interesting cartoon where you can get some ideas, some mechanical ideas to improve your creation. So to connect it, I can bring this fiber connector. I am placing it here. Okay. So the orange will be the body, the blue will be this part, the arm of the buzzsaw. I can reduce or amplify the con limit, your choice. Okay, now let's see if it works. Oh, it works, but maybe to the other side here. Let's reduce a bit torque. Let's see what happens. Ah, much better. Another example that you can add for accessories or weapons, you can bring here, okay, you can create here an arm here. Okay. Mhm. So you can use this here. So we can create here like some kind of claw. Mhm. Control D. I bring it here. So these are examples that you can use. Of course, if you have better ideas, be my guest. I want to see your crazy ideas in action. Okay, good. Group. Now let's align this one to this. Group. We can bring here this arm, the cylinder. Let's say yellow. Okay. C of cruise. Don't forget that with cruise you can have faster results. I bring here from SimLab, I bring here the axle. Let's align everything to the center if you want here. Okay, center, center. Okay. So, mobile part, the claw. This, the arm, is the base component. Okay. I can bring a pivot here. I forgot. Let's add here some torque and some speed. Again, C. Let's bring it here. Good. Mhm. Let's bring it here to the side. Let's see what happens. Mobile base. Okay. Let's see. Okay. We can reduce here the con limit to 15 or less. Control D if you want to make it double. So these are some ideas for accessories. And as you can see, now we have a crazy battle robot. So it's up to you how you improve it. Again, the saw and the claws are just an idea. Use your creativity. I know that you can get even better ideas than this. Let's put this 2 to 5. Huh. Okay, of course, both robots are the same, so they will have a similar behavior. But I expect all of you to create a different robot, and then the best projects, we will put them to compete in our classroom. Thank you very much, dear students. Good luck with your robot. See you next time.